So one more example of a Moore machine. A Moore machine is a finite automata graph that accepts inputs that can be any letters and outputs that can be any letters. In this case, my inputs are A and B, and my outputs are zeros and ones for binary to keep it simple. So let's step into my first state. Second state, notice how the outputs correspond with the numbers above the states. Second state, and then third state. So my input of B will result in the output of 0001. Okay, so my input of B will result in an output of 000 because of my loop. Okay, the loop brings it back to my initial state. Notice how this time we don't have to initiate our final state or you know how like in a finite automata you have to show which is your final state. This one, your output is your final state. So if I skip over and I step into this machine, you'll notice how my output is also different. So BBAA will result in an output of 00001. And then if I step into this machine, however A's I have and however many B's I have will result in an output of 0001. So if I have a multiple column, remember all these are just different inputs. My result is the output on each state has an output that the machine will have. So if I were to run this, and you'll notice how if you zoom in, a certain outputs have a certain like output, because you know how my output is zeros on literally 3 states, and then every time a result gets to Q3 they'll output 1. So as you can see, it's a few numbers that have reached my final state. So thank you so much for watching. The idea of Moore machines is that Moore machines have outputs and you can trace them in your programs. Okay, let me see if I can at least one configuration. Let me see if I step in it. Okay, let me see. That's me stepping in a machine. You see, one more. I just want to see the trace of how far I've come. Okay, anyways, you can't see the trace. The only place you can see it as at the multiple run. So thank you so much for watching. Please like and subscribe. Moore machines.